My name's Olivia, and I'm going to be talking to you today about Air Quality 101. A little bit about the company that I work for, which is called Sonoma Technology. We are located up north of the San Francisco Golden Gate Bridge, and what we do is we try to provide science and technology answers to air quality questions for all sorts of groups around the world. And so what that means is we work on everything related to air quality. That means from setting up measurements and instruments and equipment in the field, all the way through to looking at that data and analyzing it, and then putting out reports on the findings, and then all the way through to training and education as well. So enough about that, let's talk about air quality. So we're going to first talk about what is air pollution. So pollution is any substance, or contaminant is another word for it, that's in the air that can cause harm to humans, to animals, or to the environment. And air pollution can be thought of in two sort of buckets. The first bucket is gases, and the second bucket is particles. And we're going to talk about both of these in the few slides that we have coming up here. But gases might include things that you've heard of before, like ozone, carbon monoxide, carbon dioxide. There's a few other ones listed on the slide as well. What we'll be talking about today is the volatile organic compounds. And then particles, there's a few different types of particle classifications as well that we look at. One of those is called lead, which you may have heard of. And then there's two others that we'll be talking about, PM 2.5 and PM 10. So let's talk about particles first. So what is particle pollution? May not be something that you've heard about before. But particle pollution is a complex mixture of extremely small solid or liquids that are suspended in the air. And so these tiny particles in the air can be made up of many different types of materials. So that includes things that you may have seen or heard of, like dust. Pollen is another type of particle that we find in the air quite commonly. Mold is another one. And those three actually fall into this classification that's called PM10, or coarse particles. These are slightly larger particles in the air. They're still incredibly tiny. Their width is less than 10 micrometers in diameter. And then another one is PM 2.5. Those include things like soot, which you may have seen coming out of the tailpipe of like a diesel truck or a bus. There's organics, and then there's also metals as well. Those ones fall into the category PM 2.5 because they are typically less than 2.5 micrometers in diameter. And you might be thinking, what the heck is a micrometer? Micrometers are really hard to think about because we don't often think about that tiny of a scale. So what we can do is think about something that we do understand, which is a human hair. So if you look at one of your hairs and you look at the width of that hair is usually about 50 to 70 micrometers in diameter. Now, something that's PM10 is going to be, you could fit 5 to 7 of those particles in the diameter of a human hair. For PM 2.5, you could fit even more of those into one diameter of a human hair, right? So we're thinking about really tiny scales. But that's just to give you sort of an idea of how small these particles are. So why do we care about these, right? They're so small, they're in the air, we can't see them with our eyes. Why do we even care about these things? So it turns out that particles that are different sizes, so PM10 and PM 2.5, can affect our bodies in different ways. So those larger particles, the PM10 ones, which are represented as the green circles here, those are larger and they can be filtered out when we breathe them in from the air. Our upper respiratory system filters those out, so they either stick to the insides of our breathing tract, or we cough, or we sneeze, or we swallow, and they get absorbed into the body or expelled in some way. However, those smaller particles, which shown here in purple, those smaller PM 2.5 particles actually can get past that sort of filtration system that we have in our bodies all the way down into our lungs. So they can travel all the way down into our lungs. They can get cause breathing problems. They can worsen asthma if you have asthma. They can bring harmful chemicals into the body as well. And they can actually increase the chances of things like heart attacks or other cardiac or heart problems as well. So it's really important for us to understand how many of these particles are in the air that we're breathing, and how that might affect us and how we can protect ourselves if there are high concentrations of these in the air. So PM 2.5 as well, so it's important not just because of how far it can go into our lungs and into our bodies, but also because of what it's made out of. So depending on what it's made out of can change how harmful it is to us. Okay, so now that we understand what particles are, how they affect us, let's talk about where they come from. So some common sources of particles that you might be familiar with include burning. So those include natural sources. So if we think of forest fires, there's often a lot of smoke that comes out of forest fires. There's also some human-made sources. So if we're burning wood for our stoves, or if we're burning wood in fireplaces, that can produce a lot of particles. Cars and trucks, the exhaust pipes oftentimes produce a lot of particles. You can often see a lot of smoke coming out of some of those. Ships, so if you're by the coast or by the port, ships are producing a lot of particles into the air as well. And then also some industrial processes. So if you walk by some factories, you might also see smoke coming out of the stacks in those buildings. And those are all sources of particles. There's also natural sources of particles. So if we have a very dry parking lot or a dry field that isn't paved, that can oftentimes kick up a lot of dust, especially if somebody drives over it, or if there's some wind that kicks up dust as well. So dust is one natural source of particles. Also, if you have drought, which oftentimes happens in California, drought-enhanced forest fires are also technically a type of natural source of these particles too. So if you have lightning striking, that can cause a forest fire. That's also another source of these types of particles. And then lastly is this sort of classification or bucket that we call mechanical processes. And what we mean by that is things like tire wear. So as cars drive over the asphalt, those tires are wearing down very slowly, and those wearing down processes cause these tiny particles to be emitted into the air as well. As we brake in our cars, when we engage those brakes, that also causes friction, which produces tiny particles, usually metal particles, and those can come into the air as well. So lots of different sources of particles. This is just a few of them. There's many more that we could list as well. But just to give you an idea of where they come from. So now that we know, again, what particles are, how they affect us, and now where they come from, how do we know what level of pollution to be concerned about? So that's where this tool called the Air Quality Index comes into play. And you may have heard of this. It's often talked about during wildfire season and during smoke events. But the Air Quality Index, what it does is it tells us how clean or polluted the outdoor air is each day. And it also tells us, okay, well, what health effects might be of concern at these different levels. So if we have air quality that's in the green or the yellow category, that's usually considered satisfactory. And you can see that the description here says that air quality is satisfactory and air pollution poses no risk or little risk to anyone outside. Whereas when you get up into these darker categories, so here in red, that's sort of leveled as unhealthy air. So here some members of the public might experience health effects. If you have particularly sensitive lungs or in a sensitive group, you might experience more serious health effects. So at that point, you might want to be taking some precautions to protect yourself. And luckily, in the US, we typically don't end up in the red, purple, or maroon very often, except for when we're in wildfire or wildfire smoke events. So that's a good thing. But this is a very useful table to keep an eye on, and it's put out here by the US EPA. This is the website where you can find more information about it. So we've talked about particles now. Now I'm going to switch gears and we're going to talk about the gases, right? Remember from that initial air pollution figure that I showed you, or photo that I showed you, it showed that we had gases and particles. So now let's talk about the gases. So one very small component of gases that are in the air are called volatile organic compounds. Those are also really important for us to understand because they can often have health effects. So what is a VOC, or a volatile organic compound? So it's a collective term that's used for many gases in the air. So over here in the blue circle, I have some examples of gases that you may have heard of. So benzene, toluene, hexane, chloroform. There's a really long list of all of these, but these are just a few that you may have heard of in the past. And where do these come from? So these come from a wide variety of products and sources. So they could include things like motor vehicles. So when you drive, the exhaust that's coming out of the tailpipe of the car is not just particles, it's got gases in it too. We also have off-road machinery. So if you think about construction vehicles, things like that. Wildfires produce a lot of VOCs. Wood burning, if you use solvents, so if you think about like nail polish remover, for example, right, that often smells really strong. That strong smell that you're smelling is a VOC. That's usually acetone. Paints and other like petroleum or gasoline products as well. You know, when you're pumping gas at the gas station, or your parents are pumping gas, you can often smell the gasoline as well. Those are the VOCs that are coming off that you can smell. So how do VOCs impact the environment? So they can really impact air quality through the production of smog is a big one. And they can impact our health because a lot of them, or some of them rather, are classified as toxic. And so what that means is if you're exposed to these at high concentrations or high levels for a long period of time, that can oftentimes impact health. So we want to understand these as well so that we can understand the general quality of the air that we're breathing in. So why am I even talking to all of you about this, right? Why do we care about Air Quality 101 today? Well, we've been working with the Life is Leaving a Legacy group, and we have set up air pollution measurements around East Oakland. And so the measurements started last September and they're still ongoing right now, but you can see here that we're measuring at 5 different locations in the community, and what we're doing is collecting information on particles and on VOCs so that we can understand how what the quality of air is that you're all breathing, and so then that information can be used to try and create some change in the community if there are levels that are concerning or might be issues for people's health. So this is really a long-term study. We're right at the beginning of it, but it will help us understand levels of pollution in East Oakland. And then the stage after this one is that we're going to then go in and measure specific toxic pollutants. So we're doing this large survey first. We're looking at just what's in the air, and then we're going to go in and target, okay, which ones are the toxic ones and what levels are those specifically. So that's why I'm talking to you about this today. So you might be wondering, okay, well, how can I get involved in this, or what can I do to help this effort, right? So the first thing is use the Life is reporting tool. So the Life is website has this really cool reporting tool on it, where you can go, if you see an environmental issue in your neighborhood, you can use the QR code here. There's also a URL, and you can go and report that, right? And so that information helps us add these sort of like on the ground observations to the data that we're collecting, so then we can try and make sense of it. So you guys see and hear and smell what's going on in your community. We only see the numbers. So what we need is you guys all to try and add that human factor into the numbers that we're seeing, so we can try and help you in the best way that we can. Second is use the LIFERS website to check out what the current pollution levels are, right? So I mentioned that there was the AQI. So if you go to the LIFERS website, they have a map page, and on that map page you can actually see the data that we're collecting with the sensors. And then that will give you information about what the level of pollution is outside on any given day. So that's another way you can get involved. Another way to get involved is to use the community air sensor kits that LIFER has available. So there's 10 of these kits that anyone can check out, and you can use them to measure PM 2.5 in your neighborhood as you walk around. My colleague Paul Moon is there, and he's going to be talking about these sensors in more depth shortly, and he also has some with him that you can use while you're in the summit today. And then last but not least, if you're a teacher or an educator in Oakland, definitely ask LIFERS to access the classroom kits. We also have comprehensive teacher training available for using these kits. The kits include the sensors and all of the materials that you need to go through the air quality curriculum that's included. There's a full teacher's guide. It's a fantastic opportunity and resource for you. So definitely reach out to them. And also Paul has some flyers about the opportunity as well. So yeah, definitely capitalize on this. And with that, I just want to thank you and hope that you have a fantastic summit. And if you have any questions, my colleague there, Paul, will be able to answer them for you. Thank you.